The purpose of this video is to go over a question on the Wiley homework in 2.6. 2.6 is the chain rule. So the purpose of this question is to see if you can use the chain rule to find the derivative of this function, but then also apply the graph to find the value of the derivative or the function at x equals -2. So this point right here. So the first thing we need to do is find the derivative of this composition. So I'm going to write it like this to the 1/2 power. So that way we can see the chain rule, the power rule a little easier than the square root. So anytime we have like the nth root of x, we can write that as x to the 1/n. And then we can use the power rule to find the derivative of that. So here we take the derivative of the outside function, so that's 1/2, leave the inside function, so just like this. Then it'd be 1/2 minus 1, so this is the -1/2, times the derivative of the inside. So this is the inside function. So I take the derivative of the inside with respect to x, so that's 1 plus the derivative of the function, and we're going to have to use the graph to be able to find the value of the function and the value of the derivative at this specific point that's given at x equals -2. So first off, what is the function at -2? Well, the function's value at -2 is 8. What is the derivative at -2? Well, that's going to be the slope, the rise over run. And this is a constant slope. So we can see the slope if I go down and to the left. So I go 2 points down and then I go 2 over. So since I go down and to the left, they're both negative. So the slope here is a +1. You can do delta y over delta x, which would be -2 divided by -2, which is 1. Or you can see the slope. I go up 2 units and I go to the right 2 units. So my slope there is 1. Be careful with Wiley because sometimes the units on the x-axis are 1s and on the y-axis are 2 or something weird like that. So you have to be a little bit careful with the x-axis and the y-axis, looking at what units they're measured in, or every line is 2 units, every line's 2 units here, so I go up 1 and over 1, or I go up 2 and over 2. So I get my slope as 1. So now I need to plug in, write this a little bit nicer. I have 1/2, and then x is -2, so then I have -2 plus the value of the function at -2, which was 8, all to the -1/2 power, times 1 plus the derivative at -2, and the derivative at -2 is 1. So simplifying this a little more, I have 1/2 6 to the -1/2 times 2. So 6 to the -1/2, I could write that as 1/2 times the square root of 6 times 2, and the 2's cancel, so my answer is 1 over the square root of 6. So looking at this problem, I would get my answer is 1 over the square root of 6. So hopefully this kind of helps the process here, doing the chain rule of this composition function. So I do the derivative of the outside, evaluate it at the inside, times the derivative of the inside. And then I don't have a function to plug in -2, so I have to look at the graph. So the function at -2 is outputted to 8, and the derivative at -2 is just the slope at that point, and it turns out it's 1. So I use the graph to get this information. I plug that into my derivative here, and I get my output.